Hey everybody, this is Alex Merced from alexmercedcoder.com, and essentially today we'll be doing I think this is probably like video 6 in our 100 days of Go. Let me see here. Let me double check. Actually, we might be beyond that. Let me just double check. What number are we at? You can tell I literally just woke up. So let's see here. YouTube. Let's go to check out my YouTubes. And let's go to my channel and go to videos. And yeah, so we're on video number 7, day 7. That's where we're at. And today I figured we'd do a sort of easier topic, basically conditionals and loops. Just like how do you do an if statement in Go and Rust. and loops and all that fun stuff. So let's first go to Go. And if statements are pretty straightforward. Okay, I mean, doesn't get more straightforward than this. Should I comment this out for now? Yeah, I'm not gonna need to do anything with slices right now. Okay. So for example, I can declare a variable. So I can say, we'll just say b equals true, and then we just do if, then we put the expression, which is just going to be b. And the cool thing about Go and Rust is you don't need the parentheses around the expression. So if you've done like Python, JavaScript, not so much Ruby, mainly Python and JavaScript, you have to kind of put the parentheses around like, is this equal this, or is that equal that? Here you don't. I can just say if b, and then provide the curly brackets for what I want to happen. Okay. And undefined b. Oh, because I need the walrus operator here. There we go. Okay. And don't worry, we'll use fmt in a second. Okay, and if b is true, then we'll just say fmt dot print line, and we will print, b is true. And if it is false, and again you can do an else, and then we'll print it is false. Okay, and easy peasy. Let me just get rid of all this stuff. And then let's open up a terminal specifically in this folder. Open an integrated terminal, and then we can do go run. We can just run this particular file. So go run.go. B is true. Yay! Now, what's one of the questions that I have in any language, because I really like using things like ternary operators and switch statements. So I always like to check, do those exist? I don't think switch statements exist in Go. So let's just double check that. Switch statements. Go. Now Rust is going to have something called pattern matching, which we'll get into. Also, we do have a switch, right? Does it just work like normal switches? Yeah, okay, it's just like a normal switch. So basically, again, we use switch, then we pass in the expression. Okay, although the syntax looks a little bit different. OS equals, okay, I see what they're doing. They're declaring the variable first, and then they're saying, okay, this is the variable that you're going to do the case by. Case, okay, so that works like a pretty standard switch statement. So if you ever use JavaScript, Python, and again, if you haven't used like JavaScript or Python, or at least have one other language under your belt, this video series probably isn't like, it's not an introductory programming series. The idea here is you've learned another language or familiar with programming concepts and are interested in playing around with Go and Rust, as I'm interested in learning more about Go and Rust. But that's a pretty standard switch statement. Now, that's good to know. Although this is a neat little pattern where you can like declare the variable and then pass it as the thing you're testing against right afterwards. Okay. Cool. And then I see here ternary operator Golang. Is it gonna be do we have something kind of like that? Is indeed the automatic way to do conditionals Go. Let's see here. Okay. Let's see, as pointed out and hopefully unsurprisingly, use if-else is indeed the idiomatic way to do conditionals to go. In addition to full-blown var if-else blocks, though, this spelling is also often used. If, okay, so that's pretty much just in the statement. Similar. Okay, let's see here. I'm just trying to see if there's anything novel going on there. Okay, okay, I guess there isn't a ternary operator in Golang, so that's fine. That's fine. It's just fine. Okay. Okay, so this is just generally the way you kind of have to do it. Which is fine. You'll see like there's certain things in Golang that are a little bit more verbose. Like you'll see when we get to error checking, there are times where like something can return an error, so you have to check if there's an error before you can actually use the thing. And the idea is that like forcing you to like make sure that when you run the code that uses a thing that you verify that the thing exists. I've seen this in a few languages now, all the type compiled languages for the most part, but and TypeScript. But yeah, so that's an if statement. Now loop, there is no while loop. Okay, basically this is the opposite of what like Python does. So Python has a while loop, but no like traditional 3-part for loop. While in this language, what they do is instead they kind of make the traditional 3-part for loop everything. Okay, so which is actually I kind of like. So for example, if I just wanted to treat a for loop like a normal traditional while loop, I could just do the semicolon, skip the first part, put the expression. So while, let me just get rid of all this for now. So we'll say b equals 5 now, or actually we'll say equals 0. So for long as b is less than 5, okay, and then say basically fmt.println, and then we'll print the number 5, and then what we're going to do is do oh, I used x, it's supposed to be b. Okay, and then here we'll just do b. I don't think increments inside would go. Okay, maybe it is. Okay, so we could increment, but more proper is to do this. That's just a little bit more explicit, so it's very obvious that hey, I'm adding 1 to b. So I'm going to add 1 to b. It'll loop, and it'll keep looping till it hits 5. Okay, even though I printed 5, not b. Let's do that again. So notice what I did. If you're familiar with like the traditional 3-part for loop, normally what I would do is I would do something like x equals 0, long as x is less than 5, and then we would do like x plus equals 0. Okay. And I guess I need to do var x. Okay, let's do that. Okay. And oops, I created an infinite loop because I said plus equals 0. And notice that ran pretty fast because Go runs pretty fast. Same thing with Rust. Okay. So, but that's how that would work. So let me just change this to actually plus equals 1. Cool. Okay, that's sort of your standard for loop. You do have loops where you can loop over iterators, so again, like collections. So let's actually go look that up. Go for of loop. Okay. For loop. For. Okay. See here. Oh, this is traditional, normal. X equals the range of numbers. Nope, that's the version I'm looking for. There is a way. 5 basic loop patterns. Okay, 3 component loop, while loop. Oh, there's there a while loop? Nope, nope. That's just the normal while loop pattern using the for. Infinite loop for each. Here we go. For I. Oh, I see. Okay, so basically what you do is you have to pass in the individual item, and then this is the collection. Like slice arrays maps, something's better done for the range loop. Oh, so the range is the, I think, the keyword. Let me see here. Okay, strings is the collection here. Okay, so for range strings. So basically, the way this would work is I would first create a slice. So we'll just say b equals a slice of integers. 1, 2, 3, 4, 5, 6. And then we would say like for item slice range, which is equal come before or after the range, equals, okay. So slice would equal range b. Okay. Expecting operand unexpected. Actually, I think it's because I'm supposed to put this on the opposite side. Yeah, there we go. And then what I'm going to want to do is get rid of this line. And I want to print item. And then we're going to print fmt.println slice. Make sure, I want to see if I'm naming these variables wrong. Okay, 0, 1. Okay, got it. So this is really, the first one is really the index. This is really the index for each item that equals this range of things. So really this should be index item. And that's how you'd iterate over the things. Okay, so 0, see index 0 has the value of 1, index 1 has the value of 2, and there you go. Okay, I don't mind it. I don't mind it. Okay, so that's how that reads. Okay, and then that's just a normal like breaking a loop and stuff. Not gonna worry about that. Okay, cool. Cool. Okay, so I think we got the idea of how to do that in Go. I'm sure here there's probably some sort of like for each method that I can use to like use a callback version of looping over the slice, but I'm gonna try to stick to sort of like the normal Go way of doing things as much as possible and try to bring in third-party utilities as infrequently as possible. Because I really want to just kind of get good with the core, better with the core language. Okay, so now let's go to Rust. Okay. So again, if statements here are going to work pretty much the same way. So let's just say like let x equal true, and then we say if x curly brackets. So again, no parentheses around the expression. Print line x is true, else print line x is false. Okay, let's just open up a terminal here. Open terminal, and again first we have to compile it, so rustc run.rs, but then I also want to then immediately run it. There we go. Let's see, what doesn't it like? Help a macro with a similar name. Oh, Go with its capitalization and Rust with not capitalization. Okay, there we go. X is true. So basically like that works the same way. Okay, now once again let's check like, is there switch statements in Rust? Okay. Instead, there's this match. Okay, and this match thing always, it's like a switch but different. Okay, so let's just take a look. Okay, so match number 13. Okay, so essentially what it does is that what match does is you just say take this thing and match it against like a pattern. Okay, so I'm saying match number, so I'm matching this number which is 13, and then I'm creating all these different possibilities. So these are like your switches. But the thing is that it can be like, unlike a switch statement where it has to be like a match of values, you can match a pattern. So it's like a lot more powerful switch statement. I've seen this in like OCaml and like Haskell, a lot of the functional languages, and I get it. It's pretty cool because like, especially if you're trying to create like your own programming language, like it's really useful to sit there and like, okay, you break up a text, it's a bunch of tokens, and then you do a bunch of pattern matching to like parse the language. And your pattern matching can be like a little bit more dynamic, but it does require like a little bit more thinking than your traditional switch statement. Okay, so you basically here I'm saying, hey, if it's 1, then do this. Okay, or it can be any of these values. Okay, so you can use OR operators, and then you do this. Okay, you can say a range of values. So I can say if it's anything between this and this, okay, then do this. And then for any other situation, I would use this underscore and just say, okay, well, this does not match. So that's like your default. So essentially, you can kind of do the same thing. Typically, you're probably not going to want to write as much sort of imperative code here. So if you do need it to do things imperatively, you would then pass it in as a function. Okay. But yeah, so you can do that. Let's try that. So let's see here. X equals, let's say x equals 1. And then we do match x. And then we'll say if it's 1, print line eaches. Then we have to do a comma between each one. If it's 2 or 3, then we're going to do print line eat bread. If it's 4 through 5, and again the equals means it's an inclusive range, so it includes 5. It's not 4 up to 5. Let's make that 4 to 6. Then what we're going to do is we'll print line, okay, eat food. Oh, eat good, it's fine. Okay, and for anything else, we'll say boo. Boo. Okay, so there's our patterns. So we're matching these possible patterns, and there's a lot more ways you can do this with strings and whatnot, and again, you can like iterate over matches and all sorts of different things you can do. Okay, so let me do this. Let's actually use loops while we're at this. So what we're going to do is I'm going to create, first we'll just do a standard loop. Okay, and I think while loops exist in Rust. So first let's just do like let mute x equals 0 while x is less than 9. Okay, and then we're going to do the match. So I'll put the match in there. Okay. And then we'll do x plus equals 1 at the end here. I think I can do this. Let's see. I'm sure it'll complain. Oh no, it worked. And see, it works. So see, first it's 0, so it's like, boo, that's not one of the numbers. Eat cheese, eat bread, eat good, eat good, boo, boo. Okay. So you can do a switch statement, but again, it's called a match. It's a little bit more robust than your standard switch statement, because instead of matching the value for a particular case and saying, okay, hey, are these two things equal, you're saying, does it match these possible patterns? Okay, and then if this pattern matches, do this. And I've seen this get complicated. This becomes really useful when we start dealing with like options later. Options are a concept in Rust, kind of like a promise, not exactly like a promise. It just means like there's a possibility you don't get this thing or don't have this thing. So then what happens is that once the option, like kind of like a promise, like you can match the result against possibilities to see like, did you get the thing? And so, but you can't use it until you unpack it. So you have to use a match statement. There are some helper functions, which I wish I knew about earlier when I was first dealing with that, because I had to write a lot of match statements to unpack a lot of options, but probably not a bad exercise. Okay, so we do have a while loop. Okay, let's see if we can refactor this as a traditional for loop. Okay, so that means that, so I would probably do for, and then I would copy this piece, Control X, and that becomes the first expression. And then I would copy this and put this over here as the last expression. Okay, and then theoretically that should do the same thing. So let's see if it does. Okay, unexpected expression, mute. Okay, maybe there isn't. Loop, for in range. So for n, okay, so that's n in a range. For iterators, into iter. Got it. Okay, so no, they don't. This is more like Python, where you have the while loop, but you don't have the traditional for loop. So what I can do, if I did really just want to loop from basically for, and let me just really take a look at that one with the range again. For n, okay, so basically this equivalent one would be like for x in 1.9. Okay, make sure I'm not missing any keywords. Nope. Okay, so basically range is going to generate a iterator of numbers 1 through 9, and then it's going to loop over it, and then x will be that, and then that's that. Okay, so if I run this, I should kind of get the same result. See? Yeah, there we go. Eat cheese, except it starts with 1 because I made the range from 1 to 9. Okay, now let's see what happens if I use like an array. Okay, so we'll say let x equal. Okay, let x equal 1, 2, 3, 4, 5, 6, 7. Okay, so that's just going to be sort of an array. So I have the array, and then I'm going to say, hey, for x, or for x in, and I need to give that array a different name, r. For x in r, but again, nothing is by default iterable. Everything has to be converted to an iterable. So vectors, arrays, you always have to use like these iter methods that turn it into different types of iterables. Okay, so theoretically this turns it into an iterable, and now I'm looping over that iterable and then passing it through the match case there. Okay, something I didn't like. Oh, probably need a semicolon there. Yeah. Okay, and then yeah, there we go again. Okay, 1, 2, 3, 4, 5, 7, and it goes through the match and it works. Okay, this is cool. I think again, I like that. I wouldn't mind having something like that in JavaScript. I think there's been talks. There's ways of doing it. It's not super intuitive to try to do that in JavaScript, but I kind of like the idea of pattern matching. I think they just introduced it to Python. Okay, so let me just see here. Anything else interesting in the looping? Okay, while loop. We're just looking at match to see if there's anything else good about match that we want to. So here's matching binary. That's all fine. Destructuring. Let's take a look at that. Destructuring tuples. Let's see here how they do that. So here they use a match to destructure. Okay, so essentially what they do is that they say, okay, hey, there's a tuple match like this pattern. So you do different like tuple patterns. Okay, and just see how they do that. Oh, so what you're doing is you're declaring a variable here. So you're saying, okay, hey, this is not necessarily matching. It's just saying, hey, like, is the first value 0, and then the other values are whatever y and z are going to be. So they're mysteries, and then you can use them as you want, like, because they're variables. Okay, in this case, here you're just seeing, hey, just match the first thing in the tuple. Okay, and this is just anything else. So again, there's a lot of really cool stuff you can do with matching, because it's the kind of patterns you can pass in get pretty complicated. I'm not going to get too deep into that. Okay, let's go to guards. Let's see what guard is. A match guard can be added to filter the arm. Let's see here. So match pair. Oh, okay, I see here. So here's like you're saying a match, but only accept that match if this expression is also true. So that's all it is. You're mixing an expression with the pattern. Okay, cool. And then this sounds like it's going to probably be more like our ternary operators. Let's just see where it is being used. Sum 7. Ooh, now we're getting into options. I don't want to get into that yet. Okay. Loop. Let's see here. Oh, okay, they actually have a thing called loop. Okay, and let's see here. It's just an infinite loop. Okay, so in that case, you decide when you do the break statement. Okay, that's a thing. That's not a bad thing. Okay, cool. With that, I think that kind of achieves our mission for today of like just like control flow of like if statements and loops with Rust and Go. So good stuff. I'll see you all later. Have a great day and enjoy.